Well, good morning. Welcome to today's final installment of Strategic Farming Let's Talk Crops program. We're happy that you've joined us for today's session. This is making final planter adjustments for April and the spring season. These sessions, this perhaps season, have been brought to you by the University of Minnesota Extension with generous support from the Minnesota Soybean Research and Promotion Council, along with the Minnesota Corn Research and Promotion Council. I'm Dave Nicolai, Regional Extension Educator from the University of Minnesota. We welcome our speakers today, Dr. Brian Luck from the Department of Biological Systems Engineering at the University of Wisconsin, along with Dr. Seth Nave, Extension Soybean Specialist from the University of Minnesota. I will mention that this is the conclusion for Strategic Farming Let's Talk Crops webinar. However, we will start our spring and summer session on May 10th. So mark your calendars for May 10th. We're changing the time to earlier in the morning to allow people to get out and get their fieldwork opportunities done. That'll be from 8 o'clock in the morning to 8:30. So just a half hour starting on May 10th. And our first speaker will be Dr. Dennis Toddy from USDA ARS meteorologist. So to keep things moving along, Brian, we're going to start off with yourself. And we're going to talk a little bit about getting our planters ready. And I know at some point in time, we're going to see this snow hopefully go down in terms of that, and things start to dry out. And so I know things can happen real quickly, but there still is an opportunity or window here to do some of those last minute checks and think about your planters for this coming season. So with that, I'm going to turn it over to yourself, and you brought your slides up, and you go ahead here, and then we'll keep tabs and continue through the program through the rest of the hour.
Sounds good, David. Thank you very much for having me today. Just thumbs up quick. You can hear me. You can see my slides. Everything's good. All right. Good morning, everyone. Switch over here. My name is Brian Luck. I'm an associate professor and extension specialist in biological systems engineering. I am the Precision Ag Machinery Systems Extension faculty here. So we're going to talk about planter setups, closing wheel options for no-till corn planting specifically today. I'll stick to corn for now. I don't want to say every bit of this applies to soybeans, but I will tell you a little bit about what we've been doing in some soybean work as well. So to start off, this is usually my interactive part of the presentation, although over Zoom it doesn't work at all. So not an endorsement of any color of machinery here. It's just a color, a nice picture that I found to demonstrate what I wanted to talk about. But long story short, we're going to go through the parts of a row unit quickly, just to make sure we're all on the same page and what we're talking about here. So from looking from left to right, we have our row cleaners up front with a no-till coulter. I believe that would be considered a wavy coulter. I do have some questions about why they have those down and engaged in the soil with the nice tillage job that they've done there, but we'll leave that for the photographers to explain. Behind that, we have double disc openers. In between the double disc openers, we have a seed tube. A lot of times we have a seed firmer in there as well, depending on whether you will even seed firmers or not. And then gauge wheels on the back. Behind that, on the outside of the double disc openers, a lot of times we have, depending on the planter, we have the closing wheels in the back, or we might have smaller closing wheels with the press wheel and drag chain behind that possibly. So I know everybody in the room knows that by heart, but sometimes my Southern upbringing makes me call things a little different than what people do up here sometimes. So I wanted to go through that really quickly. So I have about 20 minutes, and 20 minutes isn't enough to address everything going on with planters. So I sort of cherry picked what I thought was important, at least in the research that we've been doing. But in the end, the overall theme, I got three points here: is plant at the right depth. It's very important. Cover the seed, close the furrow, and then ideally what we want to achieve with our planters, seed soil contact. I will go a step further here and basically say that in corn, and I think to some extent in soybeans, although I think Dr. Nave would be more, what's the word I'm looking for? More better to address this, but I think emergence rate and uniform emergence is probably what we're also trying to achieve. But all of these things, the depth, closing the furrow, and achieving seed to soil contact, all point toward that uniform emergence. And then again, there's other seed spacing and other things that we want to make sure are right as well. So I'll take you through quickly. So we've been doing some planter research for about the last 7 years in my lab. Anywhere from looking at closing wheels, which we'll talk about today, all the way to some planting into rolled and crimped cover crops, which is a whole nother system that is very interesting. We'll get to that. So right now I have a 4-row Deere MaxEmerge 2 with the vacuum row units. I'm using an Ag Leader in Command 1200 field computer, and then the electric Ag Leader electric seed plate drives. So I'm running all electric on that. And there's an additional generator that I had to put on the planter to achieve that, to get enough amperage to be able to run those electric seed plates. Most tractors, depending on planter size, don't have enough alternator or electric power on them to do that. We are also working with Dawn Equipment a little bit and running their hydraulic downforce. I think a question came in about downforce. We'll talk about a little bit about that today. We're using variable depth control as well on the Dawn Equipment side. And then they have a variable closing wheel depth pneumatic system that we have on the planter. One thing I will tell you while I bring up my picture of the planter is we plant at 5 miles an hour with guidance. So my goal in that was to plant similarly to how farmers would plant in the field. So our plots wind up being 80 feet long or so. Sometimes a little longer, depending on how much space we have. I get the tractor rolling, get it up to 5, drop the planter in the ground and go through the plots. Any assessments that we do, depending on direction of planting, are towards the middle or the end to make sure the planter reaches steady state before we make any assessments of the aftermarket attachments that we're doing, and then move on from there. Not going to talk about starter fertilizer today, but we did do a little work with starter there. And then at the back, I have changed my planter since this picture was taken, so it's a little bit old. But the one thing I do want to point out quickly is that not only do I have a 4-row planter on about 140 to 170 horsepower tractor, the question I always ask is, do 3 points on those types of tractors push down very well? Since you're not able to respond to me easily, I'll answer my own question and say no. Those 3 points are made for lifting. They can push, but just the weight of the tractor and other things, they don't push down very well. So if you look closely at the toolbar that planter has there, you see it's kind of brown and looks solid. What I'll tell you is that's full of 1/4 inch plate steel. So I have a 5,000 pound 4-row planter. And the reason for that is we were testing down pressure systems, and I did not want any of the down pressure systems to not have enough weight on the machine. I didn't want them lifting my tractor up basically and not working as they were intended. So I make sure that I have about 1,000 pounds per row that the downforce system has available to push down. Usually they're only able to push 600 to 800 pounds a piece. So we are well exceeding that and making sure they have everything available. So just so in case anybody wanted to pick on me for having such a light unit, it's not as light as it looks initially. So we did some closing wheel studies back in 2017, 2018, 2019. The story here is that I had a watershed group in Wisconsin come to me and say, we want to do no-till better. We want to do cover crops better. We want to plant into these cover crops. What's the biggest issue? We can cite a ton of issues. There's hairpinning that we have to deal with. Even getting the planter through the residue is a whole nother issue, which we'll talk about. But I told him, I said, if you had the whole state as a research farm, I might be able to get enough replications to get that study done. So let's narrow it down a little bit. And we started talking about closing wheels, kind of a hot topic. There were a lot of different shapes and sizes out there at the time. So we did some studies, a couple of things I'll point out. 2017, we had one set of closing wheels per row. That was just when we were getting started. I provided my undergraduate students with Ugga guns, battery powered impacts, and they were like a NASCAR pit crew out there pass to pass. We'd run out, rip the closing wheels off, randomize them across the rows, put them back on, make sure everything was set up correctly, and then make another pass. Got smart after doing that for 1 year, and we got a full planter, 4 rows worth of closing wheels to put on there as well in 2018 and 2019. So just the caveat is 2017 was individual rows by row. Just to give you a look at sort of what we were doing, we had the standard Deere closing wheel on there, Deere Kinsey. Have not had an opportunity to look at the Case IH closing wheels yet, but I would like to at some point. So we had a standard Deere, and then every question I always get is, how did you select these? It was the Watershed Group that came to me, and they said these were the ones that they were most interested in. So nothing necessarily proprietary here, and nothing too gee whiz about it, but I'll tell you what they are. The upper right, as you're seeing it, is a Dawn Curve Tine. The lower left is a Martin Spike. Others make spikes as well. And then the lower right is a Yetter paddle type closing wheel. So these were sort of selected because they had different modes of action, I would say, within the soil, and sort of the tillage, that we'll call it tillage, that they provide over the seed. So one thing I will warn you about too quickly when we talk about these closing wheels is, if you're using the steel type of closing wheels, I know there's Copperhead Ags, and I believe Dawn Equipment has another one out there that's sort of half plastic and half metal ring on the outside. But if you're using these steel ones, be extra careful in the depth that or the down pressure you put on them. If you have a spring on the system, usually we can run without the spring even engaged, or very most on the first notch in the down pressure system on the planter. Reason being is they're heavy, obviously. They like to dig in the soil a little bit. And one of the things we did find is, if you don't have that setting correct, even with a half a planter worth of aftermarkets and big heavy steel closing wheels, you'll start throwing seed out of the furrow pretty quickly. So just fair warning, check and double check that your down pressure on your closing wheels are right if you're using these. So looking at the 2017 results, remember this is the one where we had individual rows. We were able to get this published in Applied Engineering and Agriculture. I will tell you that this is open source, and I believe you'll have the slides and the links available to everybody here. So you can go grab this publication and read it. Anybody can. But what we basically found was no one aftermarket closing wheel at the locations that we tested them in, which was 4, I believe, 4 locations across the state of Wisconsin with various soil types, made any difference as far as no one closing wheel came out better than another closing wheel. What did happen was the aftermarket showed that they were about 2% better emergence in corn than the standard rubber closing wheel. So we started to get pretty excited about that. Statistical significance of 90% or alpha 0.01 or 0.1, sorry. We got a p-value 0.06, which was pretty close to 0.05, but you know, I'm an engineer, so I like 0.05, and R squared is a 0.99. So had to chew on that a little bit, but statistically it did come out significant in our opinion, and we provided 2% better emergence that year. What I'll tell you about 2017 is it was very pretty for planting. I don't know if anybody remembers specifically, but in Wisconsin, soil warm up happened pretty quickly. And we were able to get out there, and the soil moisture was pretty good when we were putting the seed in the ground. Wasn't too wet, wasn't too dry, nothing going on there. So in that situation with some as close to ideal conditions as you could get, at least in my opinion, we did run into 2% better emergence. 2018 and 2019. I initially got frustrated with this study, but we looked at some down pressure as well as the closing wheel. So down pressure in conjunction with. So we picked I think it was 300 or 350 PSI or downforce, pounds downforce, measuring that at gauge wheel load And then we looked at 150 downforce. So both adding downforce to the planter, just one much lighter than the other. And then we added the aftermarket closing wheels. Pay close attention to the y-axis on that graph. If you're looking at that, we did the same analysis. We saw that no aftermarket closing wheel was outperforming any other aftermarket closing wheel, so we lumped them, compared them to the standard. In this case, what I will tell you is that the soil moisture was high these 2 years when we planted. So I won't call it wet. I won't call it getting hung up wet, but it was wet when we were out there, and we just had to get the crop in the ground to make sure it had time to grow and come up and everything. The table at the right shows the emergence just based on down pressure, statistically significant difference there with an alpha of 0.05. And we saw that the low down pressure had a better emergence than the high down pressure. The difference, again, about 2% in that area. Looking at the graph, I thought I got irritated. And then I started reading through the results and thinking about it a little bit. So our standard closing wheel did the best. It was at 92.5% emergence in this replicated study. Not statistically different from the aftermarket closing wheels at high and low down pressure. And then once you got into the high down pressure on the planter, basically the standard fell off pretty substantially when it comes down to it. So worst that we achieved was 89.5% emergence, which is still pretty good, but it's not necessarily what we wanted to achieve, which was that 92.5 and higher, which the standard closing wheel did. What I will say about this is if you look at the aftermarkets, it made less of a difference what down pressure we had on those systems when we had the aftermarket closing wheels on. And what I think happened is when we put that high down pressure in that wet soil condition, we were actually changing our planting depth a little bit and planting a little deeper, which sort of makes sense in a wet soil. It's going to give a little bit, those gauge wheels are going to sink in. With the aftermarket closing wheels, that little bit of tillage that they did over the top of the seed allowed it to emerge easier. And so I like to say it like our aftermarket closing wheels alleviated some of our sins with the down pressure situation in this study. So it's kind of in a wet year, and that's where I'm at with down pressure. It sort of depends on soil conditions at planting, but what you're trying to achieve is planter ride, make sure the row unit stays in the ground, and you are trying to make sure your planting depth is exactly what you think it should be. So keeping gauge wheels on the ground, engaged with the soil or whatever they're touching, and making sure your planting depth is right. We were able to change our planting depth with this planter by putting too much down pressure on it. And then the aftermarket closing wheels kind of let us, saved our emergence in that case. So just some food for thought. Again, if you're talking about closing wheels, are thinking about getting into closing wheels, I think we did a whole planter, so both the aftermarkets on both sides. And then if you wanted to do a half a planter, I think that's fine. Just pay very close attention. Make sure half the planter's on the left and half the planter's on the right as you're pulling it through the field. Otherwise, you'll plant the prettiest sine wave you've ever seen. That's enough to scoot a planter off of its path. Downforce system, again, using springs, I think is still okay. Just making sure that adjustment's correct to keep that row unit on the ground and achieve the planting depth that you want to achieve. Active systems are able to change it on the fly. Some of them allow for uplift as well. So if you're getting in a situation where your planter row unit is just too heavy by itself, you can lift it up and out and achieve your seeding depth. Again, variable soil types across the field. I don't know Minnesota soil types very well, and I'm still learning Wisconsin's. But if you do have drastic changes going from silt to sand or something like that, having that aftermarket system allowing you to lift that up and not plant too deeply could be of benefit to you, I think. So I won't spend too much time here. I think I'm running up against my time, so I'm going to move on. I got my closing wheel recommendations. I kind of already talked about that. So we did see 2% better emergence. We saw aftermarket closing wheels do better in the wet conditions. Again, I would recommend getting a few. and trying on your soils before investing in an entire planter worth. And again, half the planter could provide some tillage and sidewalk compaction elimination to get that seed out of the ground if you are having those issues. Quick picture to show you how a real PhD works. I sit in an air-conditioned cab while people make the adjustment on my planter. That's a joke. I can't tell if everybody's laughing, but it is a joke. I do get out and work on it too. But I did want to talk about this. So we're working in, again, organic systems on this, but we're basically roll crimping a cover crop and then moving into planting right behind that. Down pressure is key, as well as planter setup. I'm going to hustle through really quickly, David, because I know I'm getting close to my time, but I got a quick picture here of us how the planter's set up. So we got a roller crimper out front and the planter on the back, cutting through that residue and planting into that. Quick video just to show you what it looks like. From the cab in Kentucky, we have karst topography where I grew up originally, so I wouldn't be able to see those sinkholes going through this field. But it is an interesting system, and we were able to cut through that residue once we laid it down flat. Get the soybeans in the ground is what we're doing with this study, and get them up through that mat and suppress weeds. So I don't know how many organic producers or advisors we have in the room, but I think we're headed this way in conventional systems as well for suppression of herbicide resistant weeds. I think it's just going to have to be done at some point. That's why I like to talk about it. We were able to reduce the seeding rate by getting the seed in the ground, riding over that residue. If you don't have the right downforce, which is the way my colleagues were doing it before they got me involved, is a problem. They were spilling about half their seed on top of the ground because the residue was pushing the planter row units up and not planting at the proper seeding depth. We did see roller crimpers suppress weeds, and we did not see any yield difference across seeding rates, which in this case, what we were studying is good. So we could put out a lower seeding rate. We did use no-till coulters in corn with a better emergence with those no-till coulters, and yield was higher with standard closing wheel than aftermarket. Wet year, other factors, and then we had that mat on top of the soil so it didn't dry as readily as it would have with row cleaners and things like that. I think this is getting close to my last slide. So just your advice for heading to the field this year: check your planting depth often. Get out and check that often. Make sure all your settings are good. You know, any maintenance that you need to do on your planter, make sure those gauge wheels aren't rattling around, the bearings are good in them. Do a test blast with the planter on the ground and functioning at speed, not just drop it in the ground, pull forward 5 feet and check it. Actually go 50, 60, 100 feet, get it up to speed before you check. Heavier soils require more pressure to get in the ground, but we can also cause that sidewall compaction. So make sure you're double checking that it's not just a smearing effect, especially if you have heavier soils, and might think about those aftermarket closing wheels to get that broken up. And the other thing I'll remind you of is planters without central fill. So using the planter boxes will lose weight as the seed box is empty. So you might get into a situation where bumping the down pressure as your seed level drops in those row units might be something you need to do. Dig at multiple locations to make sure seed spacing is accurate. I think the monitors in the cabs, either 2020s or whatever you're running, mine's on the in-command, are pretty good. Those seed sensors are pretty good as long as they're working. I still catch seed out of the back of my planter every year, just to make sure that what's coming out is what I think is coming out. So just to make sure that's okay. With that, I think I've hit my time, or maybe 1 minute over. So I will yield the floor to our next presenter.
Well, actually, we're going to take a couple of minutes here, Brian, if you can hang in here.
Yep.
Take advantage of some questions that did come in. Okay.
Great.
So in no particular order here. So it's a little bit random, maybe deviates from your presentation a little bit, but I think you can still address these. One of them that came in was, do you think seed firmers will be beneficial this year? Now, obviously, we don't know what the weather impact and so forth, but just any general comments that you might have about that.
Yeah. I have mixed feelings about seed firmers, and it's not the fact of what they do, it's more the fact of how they do it. So if you're talking about, I guess I'll call the name out, the Keaton seed firmers. They, in my opinion, tend to drag seed in the furrow. So we do all this work from an engineering standpoint on the planter to get that seed to drop exactly 6 inches apart in corn, or again, 1-2 inches apart in soybeans. And then we drag something over the top of it to send it down the furrow. Sometimes that bothers me. That said, for seed soil contact, they work. They help. They can push that seed into the ground a little bit and get that seed soil contact, get it headed toward emergence more quickly. So I guess it depends on what you put the stock in. Is it seed spacing or is it seed to soil contact? I think seed to soil contact is what you want. And if the soil is headed toward dryness, I would definitely use them when you're planting. If it's looking like it's not going to rain, that plant a little deeper and push it in there and get it touching soil and get it in the moisture is probably more important than a little variation in seed spacing across the field because of those seed firmers. The other thing I'll say quickly is there are different types of seed firmers out there. I don't know if you can commercially buy them, but there are types that are wheels instead of a stick drug through the furrow. If you can look into those and get your hand on one of those, that's what I have on my planter, because they use that to give feedback to the system to tell where the bottom of the furrow is, so they can set their closing wheels up above that. If you got a wheel with a little pressure on it, I have had to take my seed digging tool and pry soybeans out of the soil, which begs the question, and is my next research push to some of our soybean councils, et cetera, is how much seed firming pressure is too much? Can you put too much pressure on that seed, get it jammed in there too tightly and restrict root emergence and things like that? So anyway, I think I don't have a crystal ball. I can't tell you whether to use them or not. But if you're in a wet situation, probably not as important as if you're headed toward a drier climate in the next week or two after planting. It would be more important to push those in the ground.
Next question is a little bit more on equipment. I guess just in general, in your opinion, are offset double disc openers available, either on a planter or aftermarket? So again, I'll just repeat the question. Are offset double disc openers available?
I think they are. There's, I forget the name of it right now, but there's a, depending on what planter you have, I think they're just variable. They're variable diameter, and then you shim them accordingly to make sure they're contacting at the front. But they're actually serrated too. You have to do a little digging on that one. I don't have my Google right in front of me. But there are offset. They're slightly offset about a 1/2 inch, I think, is what they miss in the front to send a single lip, and it's serrated to cut through. And again, that's on I think they're made for the Deere Kinsey type planters, but I don't think the case planters are much different when it comes to double disc openers. So they might make them for those as well. So I think they are available for no-till and whatever.
Another question in terms of down pressure. If you have a system that you're down pressure with springs, I guess when is it good in a field to check, or how do you know if changing down pressure is needed? In other words, if you're out in the field and you have that ability, how do you know when you should change down pressure with a spring system, and actually when you're operating out in the field?
That's a great question. Yeah. So a lot of it comes back to planter ride, in my opinion. So if you're going through the field at speed and you look back there and your row units are floating quite a bit, you see a lot of up and down movement, and then you have to kind of get an eye, maybe somebody back there to look on those gauge wheels as well. So to make sure those gauge wheels are staying planted on the ground, running through the soil. And I know there's undulations in the field, so the row units are always going to come up and down. But if you see them doing a lot of that, and you're not hitting rocks, that's, something that's going to knock it up out of the soil, you might consider adjusting, adding more pressure to it. On the flip side, if you're running through the soil and you can see the track that the gauge wheel made, and that is below the level of the soil, top of the soil that's been untouched or at least run next to, you probably have too much pressure. That can be alleviated by, you can set your depth a little shallower and run it that way if you like, but that becomes the situation where you're starting to potentially cause sidewall compaction, or smearing. Could be one or the other depending on the moisture in the soil. But that does cause the plant to have a little issue breaking through that barrier to get its root going and to get up and get emerged. So I think with springs, I would look at planter ride first, row unit ride, and make sure that thing is staying planted to the ground and running on its gauge wheels. If you're too light, you'll be able to see those gauge wheels jumping up more than you would like. If you're too heavy, you're basically cutting a furrow with those gauge wheels, which is not good either. And the other side of that too, which, like I said, I'm not a agronomist or a soil scientist, but I know a few. They would cause an indentation right there at the furrow as well. So if you were able, if you're running gauge wheels too heavy and they're causing compaction and pushing the soil down, you might create a trench there that if it does rain, it collects water right over the seed, which could potentially be a problem as well.
In the video that you just showed a little bit ago, what was the planting date, just out of curiosity, in that rye video?
Yeah, it's a good question. So that's Organic Systems, which was new to me recently. That was in June, well into June. So what we do is we let that rye get to anthesis, which is basically pollination, and then we roll it flat. So if you go earlier than that, we don't have the luxury of chemical termination in that situation. So we have to make it terminate with the roller crimper. So we have to let it get mature enough to where when we do roll it down, that it kills it. We are looking into other systems such as mowing and a few other things, which, if anybody's wondering, plant before you mow. Learn that lesson in that system. If you mow first, you're going to drag a wad of stuff with the planter, which it doesn't work very well. But in the end, yeah, that was June, I think June 6th, well into June for soybeans, which is way later than most are used to talking about.
One thing that just came in late here is, Brian, any experience with row cleaners in terms of coming back into the field in situations? So if you have row cleaners mounted on the planter bars versus being on the row unit.
Yep. So I don't have a lot. Mine are on the row unit. I have seen planters that are on the bar. General advice for row cleaners is you don't want them digging a hole. Depending on how you get it all set up, you want them right at the top of the soil surface, maybe moving, if you have to, the top 1/4 inch of soil just to make sure you get the row swept clean, especially in corn, but you don't want them digging holes. So make sure that, when you get those set, if it's on the bar, the setting is going to be in relation to your, we'll call them carrying wheels of the planter. So basically whatever wheel and the bar and the tractor, it's going to be in relation to that. If they're on the row unit, the relationship will be between the gauge wheels. But again, it's setting them generally comes into trial and error for me. I have to get out there in the field, plan a pass, maybe get out and adjust them up and down a couple times, but you just want a clean sweep, moving mostly residue and the barest minimum of soil if you can help it. I actually saw something on Twitter this morning talking about planting into heavy residue and said, yeah, you just slam them in the ground. And if you do that with row cleaners, you're now a strip tiller, which is not necessarily the case, but I thought it was funny. So
I had one last quick question, and that is, in Minnesota, we have starting to get quite a few more planters capable of planting at high speed. Mm-hmm. And so any comments you might have about seed singulation and high-speed planters in the field in a conventional system? All right, so we're talking about with probably minimal residue and so forth, but things that you've seen or recommendation in success, after investing obviously a lot of money in this system to make it more consistent, that you can be confident that at these high speeds, you really are getting, the seed spacing, the depth, et cetera, when you're operating at these much higher speeds with today's really what I would call maybe ultra modern equipment.
Yeah, it's a good question. I have that on my list of things that needs to be tested. I don't really have a lot of experience with it. What I will say is, from what I've heard from my farmers that talk to me about this stuff on a regular basis, is that the singulation, they're happy with it. The belts that they're running on those planters catch, they've got a seed disc that feeds a belt. The belt takes it to the ground and then actually throws it backwards, the speed that you're going forward. So you basically get a dead drop where the seed winds up, which is really cool. But they're saying that they work very similar, or if not as good or better than what we've done in the slow speed in the past. That said, I will say that there's another aspect to that I like to think about, because if we're talking about high speed, we're talking about field efficiency at that point, right? So we're looking at, do I go more width and slow speed, or do I go less width and high speed to achieve the same result and get over the acres that I need to get over in the amount of working days that I have to get the crop planted? It becomes a logistical sort of issue and a material handling issue as well, which people may not think about if they're investing in that. If you're going high speed, it is acres per hour in the end, and you have to supply whatever inputs to that you're doing. If you're doing insecticide, if you're doing, obviously you have to have seed at the field ready to go in the planter, and then you have to provide starter fertilizer if you're doing that. Maybe moving more quickly could get you more acres per hour, but then you have to have the support to keep that material at the planter and keep it moving to see the benefits. So again, I don't have a lot of data, David, unfortunately, but I may be pestering some folks for letters of support to start looking at some of this stuff as well.
Well, certainly it's a trend that'll continue with our larger farmers.
Yep.
In situations with that, and maintenance of those belts and just general inspection. I'm going to bring Seth in on this conversation here a little bit while you're still with us, Brian, and
Yeah.
bridge it a little bit more on from a soybean standpoint. And maybe before you even start your slides, Seth, any comments or questions, follow up on things that we talked a little bit in reference back to soybeans, and then we'll segue more into your presentation. But I want to make sure that you get an opportunity to have this interchange.
No, it was fantastic talk. I just really appreciate the discussion around variable soil conditions and planting and adjusting to that. And I think that's the biggest, I think that's the big move in, the industry, is trying to make things dynamic in the field so that we can adjust to them. The questions I always have is, do we know what we're trying to adjust and adjust to as we go through the field? So I think it's one of those things, a little like precision agriculture. It's great if we know what the target is, but we don't always know exactly where we're going with it. And I do think our biggest challenge in Minnesota is this variable soil conditions within the field. We're gonna have wet spots, we're gonna have light spots, we're gonna have heavy spots within every pass in a lot of fields. And so that's really the challenge. And so that's why I really appreciated the point about down pressure versus interactions that you had with your closing. And I think that's exactly how these closers are being sold, is they're basically being sold to cover up some sins for improper planting, for either too much downforce or tough conditions for some reason or another. So you actually identified that directly, which I think is pretty appropriate. I will say that some of these spikes are pretty aggressive though, and you do throw some seed, and it's too bad that we have. I'm kind of rattling on here, but there's we spend a lot of time putting that seed down, firm it up in the soil, and then we come roll back through with these, do a bunch of tillage over the top of the row, and it's a little frustrating for me in my own research to see that I'm doing that same kind of thing. So I know it's happening to farmers too.
Yeah.
So
yeah, the one thing I will say about those closing wheels is a lot of them now are having gauges built into them, which is a solid wheel and then teeth sticks out, or they make bolt-on plastic parts that you can sort of eliminate. They can't go any deeper than 1 inch kind of thing, or that's the intention. So I think that's a good investment. Seth, you made a very good point there, is if you can buy the ones that have a gauge on them that don't allow them to go too deep, then it won't exactly matter that you put too much pressure on them, and you'll do less seed throwing, I hope.
Perfect.
Yeah.
Okay. So I think we put up before, we can put up again, Brian, your contact information here in the chat box so people can follow up. But if you could hang with us here for a couple of minutes yet, Brian, as we go through that, I'm going to throw it over to Seth to talk a little bit about it from a soybean perspective, because we always get this question. Your coworker, Brian, is a pretty big champion of early planting over there in the Wisconsin side. So ask Seth to maybe address that a little bit and talk about some of these other avenues in terms of resources, science for success, and publications, et cetera. So Seth, go ahead.
Yeah, let me just hit it off of that. So the question is about planting date, and I was a little, I think it was a good plan to put in planting date, especially regarding this very early planting of soybean that Sean Connolly has been pushing for a while. There's a lot of discussion about planting soybeans before corn. It's actually kind of a nuanced question. It's not about yield response or anything. I think I'm beginning to appreciate now that this question is really more complicated. And in some ways, I think that the question about corn versus soybean planting should be kind of put into a box relative to risk avoidance. And I'm now coming around to this idea a little bit that early planting soybean may not be that bad of a deal because replant costs and the penalty for replanting soybean is much lower than corn. So I think as we move forward with this discussion about corn versus soybean planting, I think this is going to have to be figured into this equation. And I think farmers may come around to this idea that they could be planting soybeans. Soybeans are fairly forgiving, and I'll come around to this at the end of my presentation about timing and emergence dates and frost and things like that. But I think the key is really around, if you're really aggressive on your early planting and you do run a risk of having to replant because of either very cold conditions and delayed emergence or even frost, that it is possible that that replanting should occur in your soybean fields rather than your corn fields. And so I think this could cushion some of this, and it may modify my own reluctance to suggest this, because I'm really a person that's always recommended planting corn. I think the corn yield response is a little bit sharper at the beginning of the year. We have a higher value crop. We're just going to make more money from that early planting corn. But I think when we figure risk into it, it does change it a little bit. But the second point there is really the key for this year, is that the whole point may be moot in terms of planting date. It's looking more and more likely that in the upper Midwest, we're just going to be going to the field as soon as we can possibly get in there, based on soil conditions. And that's always what we've recommended by universities is not look at the calendar, go by soil conditions and get in there when things look good. And then maybe even one caveat to that would be to add the 10-day forecast on that, and maybe not be too aggressive, even if we have good soil conditions. But if the 10-day forecast looks like cold and snow coming, maybe then we want to modify those decisions. So here's some historical data on planting date. I just wanted to kind of kind of give you a broader view of this. And there is a newer study I didn't get put into this figure. So this is all quite old, but there is a study maybe 4 or 5 years ago in Iowa. Most of this work is Iowa, Wisconsin, Nebraska. There is a little bit of Kentucky in here. So there's mostly I states, nothing north of the I states, but I think the response is pretty similar. Basically, what we see is a flat yield response through the middle of May, and then we see around 0.5% per day thereafter is pretty close. This is the data from Bruce Potter at Lamberton. And again, this data is a little bit dated. He started splitting plots and doing a lot of work with insecticide interactions with planting date later. And we just haven't got around to pulling all that data together. But this is a really rich data set in terms of planting dates at one single location over a long number of years. There's a couple things I want you to note. This is based on 100% a relative yield based on the highest yielding planting date within that season. So if you look along that 100 line at the very top, that means planting dates all the way from the very beginning of April all the way through the end of May. In any particular year may have resulted in the highest yield that year. So you can get very, very good yields across a broad range of planting dates. I guess the converse of that is that you can have bad planting conditions across a broad range of these as well. And so that would tip that line down. The key here is that your risk really is wider early in the spring and later in the spring. You can see these dots kind of coalesce in that first week of May. And I would say we could probably push this back a few days based on increased temperatures we've had in the region. So over the past 10 years. So I'd say this very beginning first week of May is really our sweet spot for soybean in terms of both maximizing yields and reducing our risk. Of course, there's an opportunity to maximize yields if we plant a little bit earlier. And this is some of the data that led Sean Connolly to be pretty aggressive on planting dates. And this is some work that he and I did. You can see on the right, we planted studies from 14, 15, and 16. So again, a few years ago, 3 locations in Wisconsin and then 1 location in Minnesota here in St. Paul. So mostly Wisconsin data, but a nice north-south range from the south all the way to Spooner in northwestern Wisconsin. Here's common varieties that we planted. We did a maturity by planting date study here. And you can see if we had the same variety at all the locations, meaning the more the northern locations had longer season maturities for them. And in the south, they were a little bit shorter because we had the same variety at all locations. Basically, we see the same sort of thing that we can plant through the first week of May before we start to see a tip. And then yields reduce pretty significantly by the time we get into June. One important piece to this, though, is this maturity part. And when we look at the longest maturities at any individual location, and we plot those, what we see is that earliest planting, we get a much better response when we plant with full season varieties. And so this is really the key for farmers. If you're planting very conservative maturities for your region, early planting is not going to do anything for you. It will not gain you anything at all. There's no reason to try to plant a normal, adapted, fully, a conservative maturity for your range. If you're going to plant early, push that maturity. Those are the ones that give you the greatest upside yield potential. They're going to put on another couple nodes that's going to allow us to capture this extra yield potential. A normally adapted to short season variety is just not going to do it for us. And if you look at the tail end of this, when we get into July, this figure, the way we have this relative yield here, it's 58% of the earlies or the maximums, where the longer or the shorter season varieties was 61. So basically the downside risk is no greater for these full season varieties when we plant late. In Minnesota especially, we get frost. We can have frosted soybeans. We get some yellow beans. We get some flat soybeans. Generally what I see is that those reduce our yield, of course, because of the frost, but no more than what we would have had with a normal shorter season variety. So the downside risk of late season frost is not that great for us in Minnesota. So I'm going to talk a little bit about Science for Success. I'm going to wrap this up here with a couple slides here, but One of the things that this group, multi-state group that we work with, we noticed over years is that these USDA RMA maps for early planting dates are very splotchy around the country. And the difference between Minnesota and North Dakota along the Red River was really stark. I think it was 10-day planting date, earliest planting date for insurance between, whether you're on the right or the left-hand side of the Red River Valley. And it didn't make any sense to us. So we did a bunch of modeling and provided them new nationwide data. And then they redid their maps this year that look a lot more relevant for us in the upper Midwest. And I think most people are pretty happy with those maps. And subsequently, Aníbal Cerruto, who works with me, he's a visiting professor from Argentina. He's been doing some modeling on latest frost. And what we have here is just he's just starting to go through the Minnesota data and remodel this for us so that we can come up with a new predictions for Minnesota specifically. These are our last frost dates for Minnesota, and you can see southern Minnesota, early May through mid-May as we go to the north. But frost dates and planting really, these are not really relevant contrasts for us. What we're really looking at is what date do we need to plant? What date do we need to plant to avoid having those soybeans frosted? And so trying to drag around my bar so I can see this figure a little bit better here. But basically the key here is that when we plant, it takes about 125 heat units for a soybean to emerge. That means the reality is we need to plant 125 heat units before we get a frost in order to just be within that window. So we need to plant out, we need to push that planting date a little bit earlier. We're not worried about planting on the last frost date. We want to plant ahead of the frost date and make sure that frost doesn't affect our soybeans. And we're using very conservative numbers here at 32. We're not looking at 20 degrees and freezing down into the soil. We're just looking at emergence and frost on those individual soybean plants. So what you can see here is basically we're looking at late April through early May for most of the state. And when we get in the far north, we get a little bit closer to that end of that first week of May that allows us to plant, capture 125 degrees heat units, and then have those soybeans pop out of the ground. What is a little bit interesting about this is that if you think about this 125 degrees, we have to accumulate that before those soybeans come out of the ground. And so what happens is we get some really weird things happen when we model this out. And it basically shows that when we have normal spring conditions, when things warm up gradually, it simply means that you could plant as early as you wanted, and the soybeans then will emerge when we accumulate 125 heat units. At which point, in many cases in Minnesota, we're actually outside of the risk of frost, meaning most years, most of our areas will warm up quite gradually. And so there is some differences here, and it's based on topography and tree cover and things like that affects how that warming occurs for us. So it's quite interesting that these areas with pine trees and things like this actually have more of a moderation in the environment, and we actually reduce that risk of early frost. In most cases, we can plant March 15 and have those soybeans come up for us. So I'm out of time here, but I wanted to mention Science for Success. I alluded to this earlier with this group. We've got a nice group of around 27 soybean agronomists around the country. We do a lot of research together. Some of you may have heard my talk on biologicals. We're running a biological seed treatment study this year and last. We've got a study on desiccation coming up this year that we're looking at. So we do a lot of work collectively that really improves the power of the data for us all. I think the URL for this should be in the chat. Science for Success data and all of our publications are available on the Soybean Research Information Network. This is a soybean checkoff supported location for research, and it's going to become more of a warehouse for research and extension type materials over time. This is actually a QR code. If you're able to get your camera out really quick and snap it, you could do it that way too, but the URL directly should be in the chat for you. I also wanted to mention that there is an upcoming webinar on Friday on N fixation and sulfur fertility. These are a couple studies that we did with this group around 20 or so states where we looked at both of these factors independently and also together in one of the studies. And there is, last week, we did have a session on what's new in planter technologies. So while it highlighted kind of the new flashy stuff more than the practical side that was discussed this morning, there was a nice discussion on this last week. And so you can go to and find the recording for last week's video at the link provided in the chat as well. So with that, I'm going to close up my sharing, and hopefully there's time for some more questions for both Brian and I.
Well, I think Brian had to, well, Brian, you're still there for one quick last one.
Real quick, I'm answering stuff in the chat.
All right. Any thoughts on drag chains in a conventional system? I guess that was the last question. And any thoughts on drag chains in a conventional system behind the planter?
Yeah, I don't mind drag chains. They sort of level everything out and spread out a little residue, possibly depending on what system you're in. So might keep some soil erosion happen from out of that furrow. I haven't done any work on them, so I can't say benefit good, bad, or otherwise, but they don't hurt as long as they're not getting plugged up and dragging piles of stuff behind you, not affecting the soil or the furrow or anything. It's fine to have them on there. If they're making a mess, take them off. That's my recommendation.
And I think you referred to some publications of some of the work we did in 17, 18, 19, and
yep.
And some of that's public information that folks can contact you or get to if they really want to get into these journal articles and read some more, correct?
Both of those are open access, so anybody can get at them, absolutely.
Okay, in terms of, thank you very much, Brian. I know you've got to run.
I got to run. Thanks, everybody.
You got a short commute, but we'll be in contact with that. In terms of anything else, Seth, we talked about Science for Success. There are a number of publications besides the webinar and so forth with that. In terms of that, there's a nice succinct one on planting in terms of in reference, in terms of then obviously differences here in terms of soybeans more forgiving. We do appreciate that an opportunity.
I'd like to make a quick note about this.
Ahead.
I mean, in the old days, we really, extension specialists really stayed within their own states, and we had our own recommendations, and we were highly guarded around those. And now we've just entered a new world where we're much more collaborative. We work across states. We try to develop better recommendations that are smoother across state lines, because these are artificial boundaries, really. And now with Twitter and things like that, that's what's driving a lot of these discussions that used to be done around a coffee shop. Now we're having these discussions out across the U.S. So now we're talking about very early planting soybeans. So farmers are all geared up because they see people in Texas planting corn, and they think they need to do it here. You know, and I'm exaggerating a little bit, but some of this is brought in from other states. And so now there was discussions on early planting, and now we're starting some research on desiccation in soybean, because there's a lot of interest even in Minnesota, because farmers in places like Arkansas and other places have been desiccating soybeans. And so it's not necessarily something we think that there's a big opportunity for, but it's something that people are talking about. And so we think it's important for us to do the work here as well.
Well, thank you. Thank you very much. So we want to make sure that people understand that there's a very short 3-question survey when you leave the session. Since this is the last in the series, we will be subsequently sending out a little bit longer one to everybody that maybe has attended this past winter in terms of an overall view. So expect that that survey a little bit in terms of guiding us in terms of the entire session. Remind you again, May 10th will be the start of the field notes. We'll start at 8 o'clock. It'll be a half-hour situations, and we're going to kick it off with Dr. Dennis Toddy, a meteorologist, USDA out of Ames for the first one. Then we'll have a series, obviously, state specialists, regional staff, et cetera. Maybe other industries, consultants, and so forth throughout the summer as we go forward. We want to thank, obviously, the Minnesota Soybean Research and Promotion Council and the Minnesota Corn Research and Promotion Council for their overwhelming support this past year and going forward with these webinars and programs that we have with that in terms of that. And I guess the last thing is we did put up the contact information, Seth. So if people want to follow up with individual questions for yourself or Brian Luck over at Madison, that would be more than appropriate. And finally, hopefully you've had a chance to put your name and CEU number on here because we are pulling back those people that attended live and going back once we get the CEU for crop management. Any last words, Seth? Otherwise, that's really what we've wanted to do today.
I'd like to answer two quick questions here. Imbibitional chilling, yes, this was a big deal. A lot of people talking about it. It was very niche-y thing. I think we're going to see it again. Somebody's going to find it somewhere, but certain varieties and certain physical characteristics of those varieties really open themselves up to this particular issue. And I think we had a couple years where it happened to be in locations that were really well monitored, especially in Ontario. We had some good data on it, but we just don't see a lot of it anymore. I don't think it's something that it's never been on my radar screen. So I've never been a big, never been overly concerned about imbibitional chilling per se. But
on the soybean side,
of course, yes, of course, planting in warmer soils is better. But you know what? It's Minnesota. We're going to plant in cold, wet soils. It happens. It's going to happen. It's just the way it is. And we tend to do okay. Okay. And the last other question really quickly is planting depth. This is really soil dependent. I'm kind of a shallow planter. So, 3/4 of an inch is fine, but there are soils that really seem to do, even some really heavy soils where you plant into wet soils. For some reason, they do a little bit better. I'm thinking the south central part of the state, these Clarion, Nicollet soils, Canisteos, those, I think planting a little bit deeper, even though they are clay heavy soils, they seem to do a little better. So get them in an inch. I think we're fine. But the biggest thing is get them on the moisture and watch your weather and know where that moisture is. We don't want to be in a situation where they end up drying out. That does happen, especially if we get into a year where things get really delayed and we have real variable soil moisture across the field. So that's where this whole planter technology really comes in, making sure that we get all those seeds all the way through the field on the moisture can be really helpful in that situation.
Well, thank you very much, Seth. With that, we do appreciate the panelists today and the support from our staff here at the University of Minnesota that have helped throughout the